Alright guys, let's try this counting problem. We want to form a committee that has 3 boys and 4 girls out of a class that has 10 boys and 12 girls. How many different committees can we form? Well, if we think about it, once we pick our committee of boys, that doesn't affect how we pick our committee of girls. So these are 2 independent processes going on. So what we can do is we can kind of do each bit separately. We'll count the number of committees we can make with boys, count the number of committees we could make with girls. We want the committee to have 3 boys and 4 girls, so that word "and" tells us that we're going to multiply once we're done. So that's going to be our plan of action. So our plan is as follows. First thing, we're going to count boy committees. Second thing, we're going to count girl committees. And then in the end, because we want 3 boys and 4 girls, they're independent, so we can just multiply those 2 numbers together. Okay, for the boy committee, so there's 2 groups. We have the people in the committee, and we have the people outside of the committee. And same with the girls. We might as well do it all at once. So the girls, we have the girls in the committee, and we have the girls outside the committee. Now, in these 2 groups, it doesn't matter in which order we pick the people in the committee as long as they're in the committee. And same thing with the ones outside. The ones outside also have no order. So these are our 2 groups where we don't care about order. Well, with the boys, there are 3 people in the committee, and there are 7 people outside. For the girls, it's 4 people in the committee, and since there are 12 girls, 8 of them must not be in the committee. So we'll use our formula. Here are 2 groups. This one is of size 10, so the number of committees is going to be, well, the number of objects in our set, so 10 factorial. But we need to divide by the size of each group, where order doesn't matter. So they are the boys in the committee and the boys on the outside of the committee. And similarly, let's do it for girls. So the number of committees we can make is going to be, well, we have 12 girls, so 12 factorial, divided by 4 factorial for getting rid of the order of the people in the committee, and 8 factorial for the girls outside the committee. And if we simplify these a little bit, I won't do the simplification here, but you can check. There are 120 ways of picking 3 boys out of 10. And for girls, it is 495 ways of picking 4 girls out of 12. And so finally, well, we want a committee of 3 boys and I'm going to underline "and" because that's the important word, 4 girls. So how many ways were there of picking a committee of 3 boys? Well, we determined there was 120. And tells us to multiply. Since our choices are independent of each other, there were 495 ways of picking girls. So we do that multiplication, and we get that there are 59,400 different committees we can make. And so quickly, the key to this problem is the following. we need to determine the groups where order didn't matter. And for us, for both boys and girls, it was the group of people in the committee and the group of people outside the committee. So we divided by the number of people in each factorial. And we did that, and we came up with the number of committees of having 3 boys out of 10 and 4 girls out of 12. And then, since these guys are independent and it's an and problem, then we just multiply them together and we get 59,400.